Okay, we are going to start off talking about parallelograms. I know that we learned a bit of this in the Khan Academy video, but we're going to review so that we can complete some pages in our books. Starting off, all of these blue figures, these are parallelograms. That means they have opposite sides going in the same direction. So I'm going to trace over it. You do not need to do this. I just want you to see, again, this side and this side are going in the same direction. They're both going in the same direction. But this side and this side are also going in the same direction. So I know it's a parallelogram because the opposite sides are going in the same direction. Same with these other shapes. When I look at these figures, they are not parallelograms. This one has no parallel sides. This one has one set of parallel sides, but the other sides are going to come in and eventually connect with each other. No parallel sides here. Again, on this one, you see these two are parallel, but the other ones, if they kept going, they're going to eventually cross each other. This shape is interesting because it does have parallel sides right here, and then it has parallel sides again right here, and it actually has a third set of parallel lines right here. So it's also not a parallelogram because it just needs to have two sets, not three sets. So when I come down to number 1, it says a parallelogram is a quadrilateral with, and I'm going to write opposite sides that are parallel. Opposite sides that are parallel. And then in parentheses I'm going to write going in the same direction. Bloop. There you go. The nice thing about having a video is that you can pause it to finish taking your notes. I'm going to move on, so if you need to finish writing, go ahead and press pause and then continue playing when you're done. When we go down to the next section, measuring the sides of a parallelogram, well, unfortunately, we don't have our rulers with us. So unless you have a ruler at home, you're welcome to measure the sides of these parallelograms to the nearest centimeter. But even without measuring them, I'm able to look at the length of the sides and think about what patterns I notice. Something I'm noticing is that in each figure, the opposite sides are also the same length. So, for example, had I measured this side would have been 4 centimeters, this side would have been 4 centimeters, and these two sides are actually 3 centimeters. So what I would notice is that those two sides are the exact same length, these two sides are the exact same length. Without even measuring this one, I can see the same thing. These two sides are the same length, those two sides are the same length, and lastly over here. So it says look at the length of the sides, what patterns do you see in each figure? The opposite sides are the same length. And that's all I need to notice there. When I'm dealing with a parallelogram, it's going to cause the opposite sides to be the same length, even if, for example, this one, it has 2 really long sides, and then it has 2 really short sides, but opposite sides are the same. Again, if you need to pause to finish writing, do that now. I'm going to move on, and I'm going to describe rectangles. Now, again, these are all words that you should have already learned from Khan Academy, but I'm just reviewing because you're going to be thinking about these different types of polygons here in a moment, working on your own. So this is kind of our cheat sheet, if you will, thinking about how a parallelogram and rectangle and squares and rhombuses are all different. So here it says, describe rectangles. all of these three figures are rectangles. Adel said rectangles are special kinds of parallelograms, and we did actually learn that already, that a rectangle is a parallelogram. The opposite sides are parallel. The opposite sides are the same length, but a rectangle is a parallelogram with a special rule. It's a parallelogram with 4 right angles. And if you recall, a right angle is when it makes a perfect corner. So very much like he did in the video. I could put a little tiny square right in that corner. I could put a little tiny square in that corner, and this corner, and this corner. That's what makes a rectangle special. It is a parallelogram, but it's a special parallelogram with 4 right angles. Lastly, we're going to finish up with squares and rhombuses because they're pretty similar. The yellow ones are squares, the green ones are rhombuses. Takeshi said squares are special kinds of rectangles. And they are. Squares are rectangles. They are parallelograms, their opposite sides are parallel. They have 4 right angles, just like we like to see. But the special difference is that all the side lengths are the same. So sides, a square is a rectangle with sides that are all the same length. And lastly, we'll finish up with rhombuses. Cora said rhombuses are special kinds of parallelograms. So I'm thinking about parallelograms. The opposite sides are parallel. A rhombus is a parallelogram with also sides that are all the same length. So those both kind of follow the same rule. In order for it to be a square or a rhombus, the sides have to be the same length. So I'm writing the same thing here, sides that are all the same length, period. Now, these are my class page cheat sheets for parallelograms, rectangles, squares, and rhombuses. I made a cheat sheet myself, which I'm going to put on the screen now. And this kind of covers the flow from the big idea down to a smaller idea. So a quadrilateral, any shape with 4 sides. So that's all the shapes that we've been talking about. I can call all of them a quadrilateral. But if I add on an extra detail and make it a parallelogram, well, it's still a quadrilateral. It still has 4 sides, but special rule, opposite sides are parallel. And again, I wrote they go in the same direction. Okay, that's what makes a parallelogram special compared to any quadrilateral. But then I can give it even another restriction and make a rectangle. Well, a rectangle is a quadrilateral. It has 4 sides. It is a parallelogram. That means the opposite sides go in the same direction. But it also has a special restriction that it has 4 right angles, and those are those perfect corners. So I'm putting those clue words on there to remind myself. And then lastly, it can get even more restricted and become a square. So it is still a quadrilateral, 4 sides. It is still a parallelogram. The opposite sides go in the same direction. It is a rectangle because all the corners have perfect corners, those right angles. But special restriction one more time is that all 4 sides are the same length. We just wrote that. I'm going to stick with just these 4 for now. And then later I'm going to add in rhombus and trapezoid. But I would like you to pause your video and write this cheat sheet down in your notebook because I feel like this one is a lot more useful than flipping back between those other pages. last but not least, I am about to move on to this final page where I'm going to use these 4 words as many times as I can to describe each one of these shapes. So I have to ask myself, what makes a quadrilateral? Oh, that's any shape with 4 sides. So I ask myself, does this shape have 4 sides? Oh, yeah, I'm going to write quadrilateral here. Does this shape have 4 sides? Does this shape have 4 sides? And does this bottom shape have 4 sides? Okay? And if any of them meet that quality, I'm going to write the word on this side. And when I'm done, I can cross out quadrilateral and move on to parallelogram. What is a parallelogram? Oh yeah, and I can use my cheat sheet at this point. Oh, that's where it has 4 sides, but the opposite sides are parallel. Okay, let me check. Does this one have opposite sides parallel? Does this one? Does this one? Does that one? And I'll go write it over here as well, and I'll cross it out. What makes a rectangle? Okay, it has to be a quadrilateral. It's also a parallelogram, but it has those 4 perfect corners, those 4 right angles. So which ones of these also meet that requirement? And then lastly, I'm going to narrow it down to square, where all those side lengths are the same. So I'm not doing that for you. That's going to be your job, but I just wanted to talk through it a little bit. Use this resource to help you. Use those last 2 pages we filled out to help you, and we will talk more tomorrow.